Alright, so this video might take a little while. I've got a couple things that I need to talk about, and this is to help with our preparation for the test coming up on Unit 1, which is velocity and acceleration. Now, I gave you this problem. It didn't look like this. I put it in a table. I told some of you that you could graph it, right? So this is what it looked like, and I asked, what's velocity after 10 seconds, after 250 seconds. And I told some of you that you could graph it. And if you do graph it, which is what I've done, you get a graph that looks like this. And what you immediately notice is that this is a line. And you can use that to predict where this object will be, right? Ask at 10 seconds. Well, if you have this graphed out, you can see at 10 seconds, it hits right on 35 meters per second for the velocity. And then say, what about 250 seconds? So maybe you could continue that graph on for 250 seconds. But we do know some information about, this is obviously a line, and we know some information about this. The line has an equation y equals mx plus b, where m is your slope, x is going to represent your x, how far you are over on the x-axis, which is a time. And B is going to represent your initial intercept. So there we go, the y-intercept, which at this case happens at 5. So if we were to write the equation for a line for this, it would look like this. Your y, which of course we're plotting on the y-axis, our velocity. So the velocity would be equal to the slope. Now, the slope, you can use any 2 points you want, right? So just quickly here, the slope, if you look at, these 2 points line up real nice. So this would be 5. So this point would be 5, 20. And this point would be 0, 5. If you look at the slope, you have to subtract. So y2 minus y1 would be 15 over 5 minus 0 is 3, or 5. Get ahead of myself. 15 divided by 5 is 3. So the slope is 3, right? So if we're going to write the equation, you'd have 3 times, your x values are times. So instead of x, I'll put 3 times t, plus your initial displacement is this, which is 5. And that's a velocity. It's actually initial velocity. So this is the equation for that line, right? 3t plus 5 is supposed to be a plus sign. So if I said, okay, what's it at 250 seconds? And all you got to do is plug in 250 for time. So the velocity at 250 seconds would be 3 times 250 plus 5. 3 times 250 is 750, plus 5 is 755 meters per second. So you can use this to figure out at any time, right? At x seconds, it would be 3x plus 5. And we just use that equation for a line. But if we take that equation for the line and write a more general form, right? So we take y equals mx plus b, and instead of putting m, we put the slope. But remember, let me go back here, on a velocity versus time graph, this comes from that little hierarchy, that pyramid. On a velocity versus time graph, the slope is the thing above, which is the acceleration. So instead of this, m, which is the slope, you could put acceleration there, right? So you have y equals, instead of y, right, this is the y is representing your velocity. This is the y-axis, their velocities. So you really have velocity is equal to, instead of m, we just said that the slope is the acceleration, the x value is time, plus b is your initial, it's your intercept, right? And your intercept is an initial velocity, because right, we're plotting velocities. So plus what I'm going to call vi. And this just gives you an equation, and you can see that here. You may want to write this down. In fact, do write this down. You can pause the video here to take this down, but this is the equation that we have. I'm going to pause the video real quick so I'll make sure I have the next slide ready. Alright, so this equation tells us the velocity of an accelerating object. And I mean, if that, so if you know the acceleration, you want to know how long does it accelerate for, and you know the initial velocity, you can add all that together to figure out what the velocity will be at any given time. This is sort of like a function. Its velocity is a function of time. So we can figure out what the velocity would be at any time using this. And my hint for using this equation would be that you need to identify what these different pieces are. And the best way to do that is to use the units. I talked about this in class, but acceleration has units of meter per second squared. Time is in units of seconds. And initial velocity is in units of meters per second. So you should be able to quickly see those pieces and plug them in. So let's look at an example quickly, and I'm going to kind of move fast here because I want to move on to the next one. Here you got a car is moving a velocity of 1 meter per second, accelerates rate of 2 meters per second squared for 5 seconds. What's the velocity for 5 seconds? Again, that's a lot of pieces of information. But if you just apply that equation, right, velocity is equal to the initial velocity, or sorry, you can put the initial velocity first if you want, but it's the acceleration times the time plus the initial velocity. So in this case, velocity is the acceleration is, and I see that this is the acceleration because of that unit. This is why knowing the units is so important. 2 times 5 seconds, again that unit tells me that, plus the initial velocity was 1. So 2 times 5 is 10, plus 1 is 11 meters per second is the answer. So if you know the pieces, it's easy to identify what goes where. And that's going to be even more important on the next one. So let me show you this. Imagine you had this object. Now I went ahead and did all the math and figured out, what the velocity would be, what the displacement would be. But imagine you had this, and I tried to graph this, okay? This acceleration and this time. All right, here we go. Of course, accelerations are a dependent variable. We'll put on the y-axis. Time is our independent variable. It'll go on the x. So we got 0, 0. That's the first point. So let me change my color. Okay, 0, and I'm plotting displacements. Oh, I messed up. This is accelerating. In fact, if I did the acceleration versus time, it would just look like this, right? 1, 2, and it would just go straight across at 2 because it's 2 the entire time. So let me actually put the other graph that I meant to put. We're going to create a displacement versus time graph. So displacement versus time for the same object here. So first point is for displacement is 0, 0. Okay? Alright, let me get these lines. There we go. And they're not great, but they'll work. 0, 0. Then at 1 second, it's going 2 meters per second. Okay? At 2 seconds, or sorry, it's gone 2 meters, not 2 meters per second, 2 meters. These are displacements. At 2 seconds, it's going 6. You see what's happening here? It's kind of going up very quickly, and it looks something like this. Now, I don't know if you realize it yet, but this had this shape has a name that you definitely learned in either geometry or algebra 2, and I think you learned it in geometry, maybe even algebra actually. This is half of it. If I drew the other half, it might be a little easier to see. And I've gone off the screen, so you can't actually see it. But right, you get this U shape, and in math we have a name for that, and that's a parabola. And it's really nice it's a parabola because if you talk about acceleration, and you talk about the effect acceleration has on displacement, it is quadratic. It grows exponentially. And here's that equation. So you're going to need to, again, put this down in your notes because we're going to use it. This is a big equation, I know, but it's not as bad as it looks. It looks way worse than it is. So go ahead and write down this equation. You can pause to put that down if you need to. And I think I'm still going. Sorry, my start bar came up over there. Anyways, so you pause the video and write that down. Okay, at this point, you should have that down. Now let's apply that. Alright, so here we go. So Cletus is going to compete in a drag race. He begins 20 meters north from rest. His Dodge Cummins accelerates at -3 meters per second squared. Find his position after 10 seconds. So we can use that equation for the displacement to figure this out because he's accelerating. So the equation is the initial displacement plus the initial velocity times the time plus a t squared over 2. And so you've got to figure out these components, right? So the initial, you have your initial displacement. The initial displacement tells me here is 20 meters north. Again, that's a vector, so I'm going to put positive 20. And actually, I need to make sure that I'm sorry, I'm going to have to figure out, make sure that this is actually still recording. Alright, if this is still recording, I apologize. Good, okay, it is still recording. So sorry about that, but I had to make sure it was. Alright, now, so you've got 20, and that's positive 20 because it's north. Plus the initial velocity. Well, it says from rest. Make sure you get that. It's in there, but it's, you got to see that. So at 0 times, he goes for 10 seconds. So 10's our time. Plus the acceleration. I'm looking for meters per second squared. Again, the unit is how I'm going to figure out where these pieces go. -3 times 10 squared divided by 2. Now you need to make sure you do your order of operations correctly. You must square before you do anything else. So just going across here, x is equal to 20 plus 0 times 10 is just 0 plus 10 squared is 100 times negative 3 is negative 300 divided by 2 is negative 150. And so x is equal to 20 plus negative 150 is negative 130 meters. Or in other words, he's 130 meters south. We're going to do more examples in class. I'm going to try to wrap up the video because, again, I don't want to make it too long. Please, if you know somebody who hasn't watched the video, tell them to watch the video. You've got a couple days here to watch it, but you need to get it done because on Thursday, we're going to be going right into this. So we're going to be going to practice so that I can help you all practice. And if you don't watch the video, you're starting out, this video is about 11 minutes, you're starting out 11 minutes behind everyone else. And that might not be, you may not have enough time to catch up. So please, please make sure everyone watches the video for Friday. See ya.